All right, ladies and gentlemen, it is another fun day of learning math online. This has a lot of similarities to what we've been doing, but there are some definite tricky pieces to it. The main difference is that this is a difference. Speaking of which, I believe on your copy, which is an imperfect copy to begin with because they didn't end up back to back. Why? Who knows? I believe that what I just highlighted is a plus sign. Make sure you change it to negative because the key feature that makes something a hyperbola rather than an ellipse is that subtraction sign, because you can see from the definition that it's a set of points for which the difference of their distances is the foci again, but the differences of the distance is a constant. So one of the things we're going to need today, and I just want to review it and get it on your paper, is the point slope form. We did lines every single year of your whole entire life. This is called the point slope form because basically you need to know a point and the slope. So we're going to be using this because these graphs have asymptotes in them. So when they ask us for the asymptote equation, we're going to be using that formula. We're going to use the center of the hyperbola as our x1, y1 point that it goes through. And then we're going to be using the slope as what we find for our asymptotes, which I'll teach you how to do that. So let's just kind of get a general idea. So in this particular problem, you're going to notice that it is not always true that A is not always greater than B. That is only an ellipse thing. In this problem, the A's and B's are not moving around on the bottom. If you notice, it's the tops that are moving around. They're still equal to 1. They look really similar to yesterday, but there's subtraction, and in this case, the X is first, and in this case, the Y is first. So I'll go into detail with the examples, but let's take a look at what this would look like. Whatever you see first is helping you know the direction of the hyperbola, and I see an X first. So what that tells me is that my main axis that goes through the middle is going to be in the X direction. That's called the transverse axis. It is going to go through the center, the vertices, and the foci. So it's kind of like what we did yesterday with the major axis. In fact, like that's the centered line. And so in this problem, whatever the letter is on the bottom is telling you how far to go in that direction. Just always pay attention to that. That was true yesterday also, but in yesterday's problems, always A was greater than B. Not true today. So here, this is telling me if this is the center, you're going to go A in both directions along the X, and you're going to go B in both directions along the Y. It doesn't matter which one's greater or smaller. That is going to create basically a rectangle that yesterday we would have drawn our ellipse inside of. Today in a hyperbola, since instead of sums, which would bring it together to form an ellipse, we do differences, which turns the two pieces away from each other, and they point outward instead of inward. Now, your focal points are going to, again, lie on that transverse axis. So since X was first, they're going to be on the X. They're going to be on the outside of the box somewhere. And they're going to lie inside of the curve. Just like they did with the ellipse, they were inside of the ellipse. These will be inside of the hyperbola, but they are outside of that boxed region. Now, the asymptotes that I was talking about are going to be diagonal lines connecting through the corners of that box that would have been our ellipse yesterday. Whatever is under here, that's telling you the location of the vertices. Like everything is happening on the X because the X went first. So that means these points that we first got to with our A values, those will be the vertices of our curves. And then what will happen is the curves will come in through here, and they will just follow that those asymptotes and go through the vertex and wrap around each of the focal points. That's what that hyperbola looks like. You're going to be called upon to know the slope of the asymptotes. Don't use a lot of like math magic. Just think. You're going up how far, over how far. Don't forget what you already know. Slope is change in y over change in x. So in this particular problem, the slope is b over a. And then here I'd be going down b over a. And so they're always equal but opposite, meaning one's plus, one's minus, but they have the same value. But it isn't always B over A. It depends. But that is what that type of a hyperbola will look like. Let's build the next one. And the only difference here is that they have the y first. So that means the transverse axis is going to be following in the y direction. You already know the center is going to be, opposite of H. Excuse me. Excuse me. It's always something. And then the opposite of K. And so that's true on circles. That's true on ellipses. That's true on hyperbolas. That has not changed. Your A is going to be, you're square rooting what you see. And basically both A and B in this case are telling you how far along the axis above it. So like here, this was how far to go along the X. This was how far to go along the Y. That's true here. Here the A value, and then here this is going to be samesies. Not really a word, but I do like it. So as I go through this problem, I'm like, all right, now my A, because it's under the Y, is going to go in that direction. So it might be taller, it might be shorter, it doesn't matter. And so in this case, let's say my A is here and my negative A is down here. This is my transverse axis coming through here. So I don't know exactly where yet because I don't have numbers to calculate, but these are going to be my focal points. They're on the outside of the box, but the inside of the hyperbola curves. Then here, I'll use whatever the B value is after I unsquare it, and I'll go that far to the right and that far to the left. That creates a little box. Yesterday, I would have had an ellipse inside of it. Today, I'm going to have a hyperbola on the outside of it. This is my center on this problem. So I have an asymptote coming up this way, and I have an asymptote coming down this way. Okay, these are going to be my vertices. They're on the transverse axis, and they are however far you went along that axis. So the slope here is going to be A over B because you went up A over B. The slope of the other one is going to be down A over B. Don't obsess about the A and B because you're just going to have to look. So it's either going to be plus or minus B over A, or it might be plus or minus A over B. Just look and keep in mind that you're looking for the change in Y over the change in X. Now, one thing that you have to be careful of is when you go to do the center, and I honestly make this mistake all of the time, so watch for this. You have to put the X part of the vertex first. And I'll show you what I mean when we get to our first example. Okay. Let's keep rolling. Focal length here is the same as it was before. It's how far is it from the center to the foci. So it's the same as it was before. So this is the distance center to foci. Not any different than when we did yesterday. And it's still called C. Here's a difference. You find it by C squared equals A squared plus B squared. So what I always do when I could never remember this when I first learned it, I look at the original problem. The original problems are subtraction. So then in this C equation, it's addition. Yesterday, the original problems were addition, and in the C equation, it's subtraction. So they're always opposite of one another. Okay, there's like so much information on here. It's super similar to what we've been doing. When you actually go to draw the curves, once you have your asymptotes and your vertices and your foci endpoint, that's the easy part. You just stay within the lines of your asymptotes. You go through your vertices, and it should wrap around your foci, and it should open up or down, like opening in the Y direction if it had Y first, and it should open left and right if it had X first. So you just have to pay attention to that piece, and it's tricky. So like this first example, this is just kind of a checklist. Find the center, draw the box, figure out the asymptotes, plot your foci, and then, graph that in. So let's go ahead and start. paying attention to the fact that this has y first, I already am thinking my transverse axis is going to open up or go up and down, and my hyperbola is going to open up and down. Underneath the y, so let's find the center. Let's be careful. I need the x part first. We're so used to reading left to right. I actually already made this video, and I got most of the way through it before I realized that I had made that mistake. And I'm a math teacher, so take your time. I need the x part first because it's a point. So this actually has to be 5, -2, because I need the x coordinate and then the y coordinate. So I'm going to go 1, 2, 3, 4, 5, down 2. That is my center. Check. Now I'm going to draw the box using A's and B's. Okay, so underneath the y is a 4. So the square root of 4 is going to be 2, and it's going in the y direction. So in the y direction means 2 up, 2 down. That came first. Those are going to be my vertices. B, doesn't matter which one's greater or smaller. This one's a 36. This is a 6. It's under the x. So I'll be going 6 in the x direction because every time I make a graph, it has to go off the paper. It's like a rule. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is going to be the box that yesterday would have contained my ellipse, but today my hyperbola is going to go on the outside of that. I'm supposed to find the c value. Well, c squared is a squared plus b squared. So in this case, that's going to be a 4 plus a 36. So that's going to be a 40. And so c is going to be root 40, which breaks into 4 and 10. So I have a 2 root 10 here. And that's going to be roughly 6.3 for when I go to graph. So I'm looking at that and I'm thinking, okay, it has to go on that transverse axis. And my transverse axis is going in the y direction. So I'm going to be coming down here. And so my foci are going to be 1, 2, 3, 4, 5, 6.3, down 1, 2, 3, 4, 5, 6.3. So these are my focal points, and they will end up on the inside. I'm going to have an asymptote coming through here and an asymptote coming through here. Goes through the center and goes through the corners of that box. All right. So now where are the vertices? Well, they are always on the transverse axis, however far you went up or down in this case from the center. I'm not going to learn a formula or anything. I'm going to look. It's over here. It's 2 above and 2 below my center. So that is going to put me at 5, 0 and 5, -4 for my center, for my vertices. What about the asymptotes? This goes back to the note at the very top of your paper. I'm going to need y minus the y component of my center, because they both go through that, equals m. So let's figure out what that is. I'm going to write the equation here so we can see it. Y minus the y point equals m times x minus the x coordinate. So what is the slope of this line going up from left to right? It goes up 2, and then we went over 6. So up 2 over 6 would reduce to 1/3, which means this will go down 2 over 6, so -1/3. They're always equal but opposite. So you can just write the line of the asymptote in this point slope form, because you'll do that in calc, and you'll just leave lines in that formula. So I'm going to write y, and then minus the y coordinate of that vertex will turn into a plus. And then I'm going to put both plus or minus my 1/3 as a slope value. And in parentheses, I'm going to have x minus the x coordinate. And you can just leave it like that. Okay, so when it's all said and done, I always forget to draw it. So let's go back and draw it. Got my focal points, got my vertex, got my asymptotes. So I come swoop it in here. I go through my vertex. I follow along the asymptotes, and samesies down here, and I do the best that I can. And my focal points should be on the inside of my curves, outside of the box. This one should have opened up and down because it started with y, so I am good to go. Whew. Okay, if you feel confident about doing these, then go ahead and try the packet. You only are doing the hyperbola page, not the review, not the parabola, but just give that a whirl. If you are a glutton for punishment and or would like some more information, like a couple more tries, then hang in there with me. Either me or you or my Apple Pen will just die of boredom first. Okay, so I am looking at this problem. I'm going to go ahead and group my x's. I'm going to leave it blank. And then I'm grouping my y's. And I'm putting that one second because it has the subtraction sign there. But these can get messy, and this one actually does. So I move over the 16. This is not new. This is what we've been doing. Here I'm pulling out the 4. I'm going to take half the middle squared. Oops, I cheated and wrote the 1 already. And so I'm really adding in a 4, so I'm going to put that over here. And this I don't have to do anything with. So I end up with a 4 on the outside of x plus 1 squared minus 3y squared equals negative 12, which feels wrong, but it's not wrong. It's annoying. I still need a 1, so I divide by what will make it a 1, but then I have to divide everything by what will make it a 1. So this mess on the far left actually turns into a negative because I have a positive divided by a negative. This over 3 because the 4 and the 12 reduce. In the middle, the 3 and the 12 are going to reduce. Oh, blue is an excellent choice. And then they actually turn positive. So I get y squared over 4. And then here I get the 1 that I need. So you need to write subtraction in the proper order for this to be in standard form. So I'm going to put my positive y squared term first and my negative x squared term second. And then this is in standard form. I'm paying attention to the fact that y is first. My transverse axis is going to be vertical, and so it's going to be opening up and down again. So I have to be really cautious with my center. I need to take the x coordinate of the center, which means I look at the x part, and I get negative 1, and then there isn't anything with the y, so that's going to kick out a 0. My a value is whatever's first, so this is this. Square root of 4, I get a 2, and it's under the y. Square root of 3 is sort of annoying, but that's what it is, and it's over the x. Now, for graphing purposes, I had, what did I have for my square root 3? 1.7-ish. Okay, so let's get that far. My center is at negative 1, 0. I go in the y direction up 2, down 2. Since I have a vertical transverse axis because y was first in the equation, those will also serve as my vertices. Root 3 means I'm going 1.7-ish in each direction to the left and right. Good enough to get that going. Okay. So I have my vertices, I have the little box, I can sketch in my asymptotes. They don't need to be perfect. The slope of this is going to be how far up and how far over. Well, I went up 2, and then I went over along the x, root 3. And you don't have to rationalize this at this point. There's enough going on. And here I'd have negative 2 over root 3. Because that's how far I went up and down, and then the root 3 is how far I went over. Okay, so let's go ahead and sketch our graph now. We need to find where our foci will land. I already know that if this is going to be one of my curves, my focal points have to be on the inside of that curve and the outside of the box. So let's see how that plays out. So to get c, remember, we do c squared equals a squared, which was 4, plus b squared, which is 3. So we end up with c equaling the square root of 7. And the square root of 7 for graphing purposes is about 2.6. So to graph those foci, I'm going to go from my center up 1, 2.6, and down 1, 2.6. So they barely land inside of those hyperbola branches, but they're in there. And because they're close to the vertices, that's why this parabola is a little bit tighter versus the last one. When the focal points were out so far, it made the hyperbola a little bit wider. And I feel like I might have just said parabola, so who knows? All right, so my vertices are just those 2 points that I drew. So I can go from the center up 2. So that would be at -1 up 2. And then the other one is right here, which is at -1, -2. So, I mean, just use counting, use your brain more than you're trying to use formulas or memorizing, because that just never works. All right. So if my center is this, let's build our asymptote equations using the point slope. I'm supposed to go y minus the y coordinate, but the y coordinate is 0. Handy. Plus or minus my slope, so 2 over root 3. Then I'm supposed to do x minus the x, so it turns into +1. Always. All right. So again, if you are okay and you're going to be able to graph and find information, you can go and have at it. If you want to torture yourself with one of these where you have the information and you have to build the rest of the equation, we can do that too. Okay, so let's go for it. Vertices. Okay, so 1, 2, 3 down, 1, 2, 3, 4, 5 is one vertex. 1, 2, 3 up 1 is another vertex. Okay, the center has to be halfway in between them. So if you want to, you can do math. You can take this x plus this x and find halfway in between. This x plus this x and find halfway in between. You're going to get 6 over 2, -4 over 2, otherwise known in the math world as 3, -2. This will be going with the x part of the equation. This will be going with the y. If, which they are, because they said so, these are my vertices, then keep in mind, again, because apparently all the examples have this, I'm going to have a transverse axis that is vertical in the y direction, and that means y gets to go first in my equation. So I'm going to have equals 1, square here. I need to have y first, but I'll have to have a +2 with it. And then here, I'm going to have my my x second, and then I need to bring down my x coordinate from the vertex. Okay, what I don't know is what's going to generate these bottom numbers. So let's figure that out. The other thing that I need is my a and b. Keeping in mind, it doesn't matter which one's bigger. I just have to kind of figure out where I'm going. So since this is the transverse axis vertically, I'm going up and then over. And so whatever I'm doing going up is going to be under the y, if that makes sense to you. So since these have slopes of 2, my slope of the positive one is a 2, and that is going to be going up and over, and that's going to be a over b, because I'm going up. Like, this has to be an a squared, because that's how these formulas always are. Those a's and b's never change direction. And since the a is going to end up under the y, that's going to be my y over x change. So what do I know? Well, I know that my center's at 1, 2, 3 down 2. And so then my a means how far it was to each of these vertices. So I'm just going to count. My a is going to be 1, 2, 3. It's 3 units from the center to either vertex. So this turns into 2 equals 3 over b. Multiplying the b up, dividing the 2 down, I end up with a b value of 3/2, which is sort of unpleasant. But we're in honors pre-calc. So that means in my graph, I would go over 3/2, which is 1.5, and then 1.5. That's to the left and right. Now I have this little box. I have my vertices. I have my center. I'll be able to find my foci. And I know that it is a transverse in the y direction, so it's going to be opening up and it's going to be opening down. So a is 3, which means that this is going to be a 9. And then this is unpleasant. and you can leave it as a fraction in the bottom if you want. Since b was 3/2 and I need to square it, that's going to be 9/4. So you can write it like that. Now, if you're a mathematician, oops, I made a pretty significant mistake there. I got to make sure I have a negative. If you are a mathematician, you're going to remember that dividing by a fraction is the same as multiplying by the reciprocal. So you can certainly have it like this. Both of these are perfectly legitimate for our only 1-day lesson on hyperbolas. But keep in mind that that first thing is always a. And so it doesn't matter which one's bigger. Now, what I didn't find is the focal length. It doesn't tell me I have to, but if I did have to, I would find it by doing a squared plus b squared and going from there. What I do know is that my focal points are going to end up in here somewhere because they have to be on the inside, they have to be on the transverse axis, and they have to be greater than that box was. So that's a lot, OMG. So I'm going to upload these into the filled in notes. They're going to be exactly this and exactly this messy. So hopefully you are able to make some head or tails of that. And then work on whatever is going to be the best use of your time. If you have no idea how to do hyperbolas because you just don't get it, then a smart thing to do would be either finish up your circle and ellipse worksheets, or maybe start looking at the final exam stuff if you want to. And then I can help you when I get back. Otherwise, ask around. Somebody out there is going to have an understanding of these. Basically, you're drawing the same box you would have drawn for the ellipse. You got to take time in watching for the center because the X and Y's are moving targets. Once you have that box nailed down, you can count the slopes and for the asymptotes. And you can just draw that hyperbola facing out of the box instead of going into it to create the ellipse. So hopefully somewhere in here you can be like, hey, this is not actually that different. I'm not doing anything super significantly different. I'll stop talking at you and I will get this loaded up, and I will for sure see you on Thursday.